Welcome. We're going to do Module 6 Homework 2. Now, Module 6 Homework 2, this video is going to be relatively short because we only have 3 examples of this. So, this is a section about solving equations that have radicals in them. So your steps are this. You isolate the radical first. This is a crucial step. If you don't isolate the radical first, you will get an answer that's wrong, an answer that does not make the original equation true. So you've got to be sure you do that first. Once you do that, you're going to raise both sides to the appropriate power. You'll see what I mean by that. Then you continue solving the equation, and then you check for what are called extraneous solutions, and we will get to that eventually. So let's do it. We're going to solve this equation. Step 1 has to be to isolate the radical first. So that means we need to get the 1 off of that side by subtracting 1 from both sides. That will cancel that. You will get 7 on the right, and you will get the square root of 3x plus 2 on the left. Then you may remember that if you have a square root that you square, the square cancels the square root. So I'm going to square both sides. Now be careful with this. Maybe I'll leave this comment for a little bit later. So let me just continue with the problem. So the square cancels the square root. We get 3x plus 2. And 7 squared is 49. And then you know how to solve that. I'll go through the details, but you know how to solve that. Subtract 2 from both sides. You get 3x equals 47. Divide both sides by 3. And we end up with x equals 47 over 3. And that is your answer. But when you solve an equation involving square roots, sometimes the answer you get, even though you did everything right, does not work. When that happens, the answer is called an extraneous solution. Now that's kind of a bad name because extraneous solution sounds like you have a solution, but it isn't really a solution. So you have to go back and check to see if this works. Now you might think, okay, well, I'll plug it into here and see if it works. That's not enough. The original question did not ask you to solve this equation, so it doesn't matter if it works in that equation. What matters is, does it work in the equation we were supposed to solve? So go take the equation we were supposed to solve and plug it into that and see if it works. So we're going to replace the x with our answer. We're going to have the square root of 3 times 47 thirds plus 2 plus 1 equals 8, and we're going to see if that's correct. Let's get rid of this, and let's solve that. The 3's cancel here. I hope you know why. So that gives you the square root of 47 plus 2 plus a 1 there equals 8. That's the square root of 49 plus 1 equals 8. The square root of 49 is 7, so that's 7 plus 1 equals 8. And that is clearly true. So that means our answer is correct. So the answer is 47 thirds. Okay, let's do the next one. Again, when you have an equation that has a radical in it, you need to isolate the radical first. So we will add 9 to both sides. You're now going to have 5 times the cube root of 4x minus 1 equals 10. Be careful. You have to isolate the radical. I see many students do the wrong next step. The radical is not by itself on this side yet. There's still a 5 out there. So the next step is to divide both sides by 5. When you do that, the 5's cancel. You get the cube root of 4x minus 1 equals 2. Now the radical is by itself. So now we're going to raise both sides to a power. Let me erase this stuff here just to get this out of our sight. We're going to raise both sides to a power. Since there's a 3 in the corner, to cancel out the cube root, we have to raise both sides to the third power. On the left side, the cube root cancels the cube. You get 4x minus 1. On the right side, you get 8. Add 1 to both sides, you get 9. Divide both sides by 4, you get 9/4. And that is the answer. Okay, I'm going to say a little bit something different in a moment than I'm saying right now, but let's get this first. So, what do? You check your answer. How do you check it? You go back to the original equation, exactly as it was originally written. You plug it in for x and see if it works. So we're going to have the cube root of 4 times, instead of x, you're going to put in place of the x, the 9/4. You still have the minus 1 in there. On the other side, you have 2. Wait a second. Is that the original equation? Let's go back here and see. No, sorry. Excuse me. That's not the original equation. We're going to go back to the original equation. So we're going to plug our answer into that. We're going to plug our answer into 5 times the cube root of 4x minus 1 minus 9 equals 1. So we're going to have 5 times the cube root of 4 times whatever our answer was, minus 1 minus 9 equals 1. Let me scroll down and find our answer, which was 9/4. So we're going to put our 9/4 in there for x, and then we'll simplify. So we have a 5 on the outside. We have the cube root of, the 4's cancel, so we have 9 minus 1. We still have the minus 9 equals 1. So that's 5 times the cube root of 8 minus 9 equals 1. Well, the cube root of 8 is 2, so that's 5 times 2 minus 1 equals 1. So that's 10 minus 9 equals 1. That is clearly true. So that means 9/4 is the correct answer. Okay, I'm going to tell you something that would save you a lot of time, but you don't really need to know it, and that's this. If your radical has an odd number in the corner, you don't have to check the answer. As long as you did the math right to get to that point, your answer will work. If your radical has an even number in the corner, like the last example did, then you have to check because it might not work. But if you don't want to learn that rule, then just always check, and then you'll be fine. Okay, let's look at the next example. So for this example, we have a square root of x minus 1. Remember, when you have a square root, that means you have a 2 in the corner. And since the number in the corner is even, we will have to check our answer. So we've got that plus 8 equals 5. We'll isolate our square root by subtracting 8 from both sides. That's going to give us the square root of x minus 1 equals negative 3. And now we're going to square both sides. The square and the square root cancel, giving us x minus 1, and the other side is 9. Add 1 to both sides, and we get x equals 10. Okay. We started with a root that had an even number in the corner, so that means we have to check 10 in our original problem. So let's take our original equation, and let's replace the x with 10 and see if it works. So we're going to have the square root of 10 minus 1 plus 8 equals negative 5. So we'll have the square root of 9 plus 8 equals negative 5. The square root of 9 is 3. So we get 3 plus 8 equals negative 5, and that is false. Since that is false, that means 10 does not work. Since 10 does not work, we throw it out. There were no other solutions to the problem, so that means the answer is no solution. There is no number that makes that original equation true. Suppose when we solved the problem we had two answers. Let's say the answers were 5 and 10. And let's say 10 did not work but 5 did. Well, then 5 would be the answer. But we only had one answer to start with, and that one didn't work, so there is no solution. I want to scroll back for a moment. I thought there was something else I wanted to say. I know it was optional. I don't think I'm going to remember what it was, or maybe there was nothing. Okay, that's how you do it, and that is the end of this recording.